For this problem, we need to evaluate several different trigonometric functions. The first one that we want to look at is A here, is the sine of pi over 4. Recall that the sine is the same as the y-coordinate of our point at that angle. And so if we look for pi over 4, we can, which is that 45-degree mark right here. Let's see if we can move that here. There we go. And we look at what the y-coordinate of that point is, and it is simply square root of 2 over 2. And so that is our answer for part A. For part B, we're looking to find the cosine of negative 2 pi over 3. Well, the first thing we have to do is figure out where that particular angle is. If you look at the negative angle, means that we start at 0 and we're going to go this way. If we go pi over 3, we end up down here. And if we go another pi over 3, we end up over here at that 4 pi over 3. So what we're doing is we're essentially starting at 6 pi, or not 6 pi, starting at 2 pi, and then going back 2 pi over 3 from there. So this value here is equivalent to the cosine of 4 pi over 3. That's the same, it's coterminal angle. And the cosine, of course, is equal to the x-coordinate, and if we look at the x-coordinate at 4 pi over 3, that is equal to negative 1/2. So that would be our answer for part B. In part C, we're being asked to find the tangent of 3 pi over 4. Now, one of our definitions for the tangent, we can define it in terms of the sine and cosine, and the tangent is equal to the sine function divided by the cosine function. So if we can find the sine of 3 pi over 4 and divide that by the cosine of 3 pi over 4, we'll be able to find our answer. Alright, so let's take a look over here at our unit circle again, and let's see if we can find 3 pi over 4. 3 pi over 4 is a little less than our 180 degrees, and it's right here. 3 pi over 4 is 135 degrees, and we have an x-coordinate of negative square root of 2 over 2 and a y-coordinate of positive square root of 2 over 2. Well, the sine is the y-coordinate, and the cosine is the x-coordinate. So in this particular case, what we're going to have, the y is positive square root of 2 over 2, and the x is negative square root of 2 over 2. And anytime we have a complex fraction, remember we can multiply by the reciprocal of the denominator. So we can flip the bottom over. You'll notice all sorts of fun things start canceling out, and we're just left with 1, and it was negative because we had a positive divided by a negative. So the tangent is equal to negative 1 at 3 pi over 4. For part D, we're being asked to find the secant of 7 pi over 6. And if you look at our picture, we can find the angle 7 pi over 6 is a little bit more than pi. So we're down here at this 210 degrees right here. You can kind of see that a little bit. And we have our x and our y coordinate. Well, the secant isn't one of our standard cosines and sines, but the secant is equal to 1 over the cosine. So what we have here is 1 over the cosine of 7 pi over 6. And we just found out that the cosine is the x-coordinate. And so the x-coordinate at 7 pi over 6 is negative square root of 3 over 2. So what we have is 1 over negative square root of 3 over 2. Again, we have a complex fraction, so we can multiply by the reciprocal. So 1 times 2 divided by negative square root of 3. And so now I have, well, that's just 2 over negative square root of 3. But this isn't a very nice final answer because we don't like square roots in the denominator. So to rationalize it, we can multiply by square root of 3 over square root of 3. And we'll come up with a final answer here of negative, we'll make sure that's negative there, 2 square root of 3 over 3. And that would be our solution for the secant of 7 pi over 6. All right, so far so good. What we're going to do next then is we have 2 more parts, E and F, so let's take a second. We'll clear off some space on our board, and we'll continue those here next. All right, now that we got a little bit more room here, let's take a look at part E. For part E, what we're looking to do is to find the cosecant of 150 degrees. So if we look over here on our unit circle, 150 degrees is right here. Cosecant, we'd like to know what that correlates to. Keep in mind that the cosecant is 1 over the sine of 150 degrees. And the sine is the y-coordinate. So what we're really looking at here is 1 over the y-coordinate of that 150 degrees. So our y-coordinate is 1/2. So what we have is 1 over 1/2 for the y. Can multiply by the flip, which is 2 over 1. And we end up with the cosecant of 150 being equal to just plain old 2. The last part of the problem here is F. In F, what we're looking to find is the sine of 17 pi over 6. And if you notice as you look in your circle, the biggest pi over 6 expression that we have here is 11 pi over 6, and then this is 12 pi over 6, which is back to 2 pi. So we need to find the coterminal angle that goes along with the sine of 17 pi over 6. If we go all the way around, that's 12 pi. So then, or 12 pi over 6, 13 pi over 6, 14 pi over 6, 15 pi over 6, 16 pi over 6, and 17 pi over 6 here at 150 degrees. So basically all that we did is we took that 17 pi and subtracted 2 pi, and we end up with 5 pi over 6. So that will have the same value of sine. Sine of any angle is equal to the y-coordinate, so all we need to do is just look for the y-coordinate there, which is 1/2, and that is our answer for part F. All right, good job.